microphone in my talk. So I'm going to talk about a collaborative project between the Nature Conservancy and the Climate Impacts Group, where we're working to integrate climate impacts into regional policy and funding programs in Puget Sound. So this is going to be a two-part presentation. First, I'm going to talk about the local context and what we're doing to develop our understanding there of the community information needs, data needs. And then Guillaume is going to talk specifically about the science. Our goal in this is to marry these two parts and really have these two parts help inform our regional funding program. And I'll give example of two different projects that we're working on. I want to say this is very much, so this first presentation is going to present the results and some insights from interviews we've been doing in two focal watersheds over the last few months. This is very much a scoping project and a work in progress. We've just completed the interviews this last week. So local context matters, right? I mean, maybe that's a little obvious a statement to start with, but when you're talking about climate impacts, it's really important to think about where that climate is changing, right? So this is the Skagit River, for those of you familiar with this area. It's the largest river coming into Puget Sound. I drive across this bridge every day when I go to work, so I know it really well. It's relatively high elevation watershed. It's a big watershed coming out of the Cascades. And so as the glaciers recede and we lose the snowpack, where the climate projections are for a pretty dramatic change in the peak flow events. So a 50% increase in your peak flows over the next 60 some odd years. So that's a pretty dramatic change as we look forward. Consider the impacts here and compare that with the impacts here. This is the exact same river, but very different impacts. And here, I would argue the most important thing is the timing of when those peak flows happen, because most of the impacts are going to be on some really important agricultural lands. You can also contrast that with, this is another Puget Sound floodplain. This is the Puyallup River, so we're now south of Seattle. And this is a really important economic area for the region, but it's also an incredibly vulnerable area in that you have the Puyallup River coming down from the headwaters of Mount Rainier, so a very steep river, and it's a very confined, as you can see, there's a lot of development in the river system and in the floodplain, so it's a very confined and hemmed in system, and at the mouth you have the Port of Tacoma, which is really confining the river as well. So here, one of the big issues in the Puyallup is the sediment load, and Eric is going to focus on that in our last presentation. But there's a lot of sediment filling up this really confined river basin. But again, you have a system that's expecting some pretty dramatic changes in peak flow events. So there's a huge economic impact of that here. So I put these up just to illustrate the importance of understanding the local context of where we're trying to work and integrate the science. So this project has three goals. The first one is understanding the science and how climate change is going to impact floodplains and floodplain management. That's the piece that Guillaume will focus on in the next presentation. And the second two pieces are where this presentation is focused on. So what information is needed about the local context to really develop smart floodplain management tools and decisions, and then I'll provide two examples. So our two focus watersheds for these interviews were the Stillaguamish and Puyallup watersheds. We interviewed over 30 people in these watersheds, and we really tried to get as diverse a representation of stakeholders as we could. So we talked to tribes, we talked to city planners, we talked to farmers, stormwater managers, a variety of different people in these watersheds to understand their perspectives and what the concerns were as they look at climate impacts in these watersheds. So quick introduction, the Stillaguamish River, we're now north of Seattle. It's a relatively small watershed. It's actually pretty interesting because it has a disproportionately large floodplain for a small river. But flooding is common in this river, but it's often described as a very flashy system. So storms come through and they go through quickly. It's actually a lower elevation than some of the other watersheds that we work in. It's largely an agricultural, very little development in the Stillaguamish. It's also a completely unregulated watershed, which is an important thing to consider when we think about flooding impacts going forward. In contrast, the Puyallup watershed is a very high elevation, starting at the headwaters of Mount Rainier. It's very large. It covers 2 counties. There's approximately $2.7 billion of assessed value within the floodplain itself, and highly developed as you come down, as I mentioned. This watershed is somewhat regulated, but not entirely regulated. So the water management can take off some of those peak flows, but it's not, the modeling shows that it won't be able to account for all of the flooding expected in the future. So we went out and did these interviews and basically started with some really simple questions, a series of questions around how does today's weather impact you? So we're just trying to talk to a diversity of people and understand what they're seeing today. So that's kind of where we started. I should say that we were conducting these interviews this summer during this very extreme drought. So that was obviously on everybody's mind and something that we heard a lot about. When we asked these questions, overwhelmingly, the responses kind of fell in these 4 categories in terms of the impacts that they're seeing today and how it impacts what they're doing. So low flows, there's a lot of concern about salmon. There was some less extent concern about winter flooding, but again, the timing of when we were doing these interviews is important. We're in the middle of a drought. There is some discussion about extreme precipitation events. People are noticing those are increasing. One of the interviews we did was in a small town called Arlington at the foothills of the Cascades, and a quote that sticks out in my mind is that, people are used to the Arlington drizzle, and those of us in the Pacific Northwest know that, but now we're seeing these really different systems, right? It's not just the regular drizzle, there's some important monsoons. And warmer temperatures, people are noticing that. Certainly farmers are noticing that, but also it's a huge concern. It was a huge concern this summer for fish in these rivers. So that's today. Now, when we look forward, the next series of questions we asked, okay, well, that's what's happening now. When we look towards tomorrow, how do you expect that to affect what you'll do? And I should say that when we went into these interviews, we had developed it sort of a 2-pager of basic information for each of these watersheds about future projections, changes in flows and sea level rise and other parameters. So here, a similar story. We again heard about drought, we heard about flooding, and to a lesser extent we heard about sea level rise. But interestingly, the results when you looked forward, we heard a lot more diversity about how the drought or warmer summers, drier summers would impact these people in the watershed. So whereas today it was predominantly about fish, when we look forward, we heard a lot more about economic development was a big concern. Is there going to be the water wells to support development in these areas where there's tremendous development happening right now? There was a lot of concern among farmers in the water rights, the evolution of that puts farmers very much at risk, and there's a lot of uncertainty looking forward. So it was interesting to see how with the future uncertainty and how things are going to be managed, there was a lot more variety and answers around that question. The increasing winter peak flows is a big concern, as a lot of these areas already have some chronic flooding problems. So again, that comes up. And interestingly, I found it interestingly that not as many people were concerned about sea level rise. And we were talking in 2 watersheds. I should have mentioned this Still-Squamish especially is a low elevation watershed. There's a lot of farming, so there's a lot of subsidence of that land. And so sea level rise and being able to farm in those low elevation coastal areas is something that I would have thought we heard more about, but it hasn't quite raised up yet. Our next series of questions was, okay, well, that's what can we do about it? And not just like what can we do about it in terms of reduce emissions, but specifically in your watershed, what are the actions that you see should be a priority and can really help us develop better floodplain management strategies. And this section of questions I found really interesting across the board, both in the Stillaguamish and the Puyallup watershed. We heard a lot about upper watershed management. And can we manage the forest in the upper watershed basically to function as natural buffers, either to retain more water for summer flows or to kind of take the peak off the peak flows, the big storms in the winter, the atmospheric rivers. And I think it's important to note that there's a lot of unknowns here. We don't know how upper watershed management really impacts the water, the hydrological system, but people are starting to really look upriver. That's at least what I took away from these interviews. There's a lot also discussion about land use policy and planning. So I come from more salmon recovery world where there's a lot of focus on projects, and now we're starting to see people are a lot more interested in how we can change policies and planning to address these changes. And there are some specific examples about how the Growth Management Act, for example, doesn't promote good behavior. It's actually encouraging more development in high-risk areas. So that's kind of an important shift, I think, to be transitioning from people thinking about projects, they're going to do their little project right here, to thinking about the importance of these long-range planning efforts. So I mentioned that we just finished these interviews last week, and Laura at the Climate Impacts Group is very busy analyzing the data, so I'm just giving you some of my key takeaways from it. But I think it's fair to say that it was really interesting to go into these interviews and sit down. And the big thing for me was that there was a lot of discussion about trust building or relationships and importance of leadership. And, we know that's important, but when that's being reflected back at us, when we're trying to give them climate information, was really interesting. This quote from a city administrator from Stanwood, it really kind of illustrates that for me. And I just want to point out, this is probably from a climate perspective, probably like your worst case scenario, right? Like Stanwood is right in the center here. It's basically sandwiched between on the north side you have the Skagit River and the south side you have the Stillaguamish River. So you've sandwiched at the mouth of these two rivers. You have low elevation agricultural land that's subsiding. You have sea level rise. And on top of all that, you also have a lot of development happening in the hillside. So all that runoff is coming off. So in terms of downtown Stanwood, it's probably in the worst place you could imagine. And the point, though, is not that we're going to pick up and move this town, but there's a lot of investment. It's small town America that people that have their businesses on that Main Street downtown have a lot invested in there. And so they're starting to think about, maybe there's a need to move it, but it's not going to happen overnight. This is a process. And building those relationships and building the trust and the partnerships and having the leadership to do that is what's going to make this move forward. Not necessarily, the limitation is not necessarily the data and the science right now, but really the partnerships and the relationships to make those changes, those transformative changes to really create resilient systems. So now I want to switch gears. That's kind of what we learned going out and trying to understand the local context. I want to talk about how we are then taking that information and using it to inform regional funding programs. So I'm going to talk about two different programs that are happening in Puget Sound. One is the Regional Conservation Partnership Program, also more commonly known as RCPP. Some of you may know this program. It's 2014 Farm Bill provided funding to support local public and private partnerships that support stewardship on agricultural lands that have conservation benefits. So Puget Sound received $9 million special designation for these projects. And the projects are being implemented by a new group called the Puget Sound Natural Resource Alliance. So the Nature Conservancy has been very involved in getting that funding for Puget Sound, that special designation. And our goal is to really help the Alliance understand, okay, how can we develop a program and give them a framework for where you can make investments that you can get the biggest benefits. So whether that's salmon benefits, whether that's shellfish benefits, resilient benefits, in terms of adaptation. So this is just an example of the analysis that we're doing. It's a pretty basic spatial analysis, but we're trying to overlay, okay, here are your salmon priorities, here are your shellfish priorities, here's the areas where you need clean water, and then we can add in the climate lens. So this is an example looking at using Norwest data where we expect stream temperatures to be changing the most going forward. The thinking here is that if we do BMPs, if we focus our best management practices in agricultural lands in these areas where the stream temperature issues are the greatest, then we're going to get the bigger benefit from these projects. So this is kind of how we're trying to help them prioritize where to distribute that funding in Puget Sound. That's super quick overview. I'm happy to talk more about that program. The other program that we're working on and trying to incorporate climate change into the funding program is in Washington State. We have the Floodplains by Design program, and the intent of this program is to really develop integrated projects. So historically we have flood control and salmon recovery projects happening in the same stretch of the river, but implemented and designed by entirely different agencies and entities, and they weren't coordinated at all. So this effort in Washington has been really successful, and I would say remarkably successful in a time of very constrained state funding budgets in generating funding for projects that integrate those two. So the intent is to integrate salmon recovery, flood control, and other community benefits. So over the last 2 years, it's gotten $80 million to support projects in these watersheds. Here's an example of a Floodplains by Design program. This is near the town of Ording, Washington. So in the light blue, you can see these are areas where there's basically been a levee setback, and these big areas, these two projects are reconnecting pretty substantial areas of floodplain to the river. Especially this one downriver is a great example of where this side channel was completely disconnected. So it's providing fish habitat, it's allowing the water, it's providing great flood conveyance. You know, the water can get through the system quicker. So we know a lot about flood conveyance and flood storage of these projects, but what we don't know a lot about and what we're trying to look at now is how can we design these Floodplains by Design projects to also provide important climate benefits. So whether that's restoring cold water refugia or reconnecting, recharging groundwater, you know, what are some of the ways that these projects can also provide a climate benefit, and let's design them in a way that they really maximize that benefit. So I like to end with a story of Ken Wolf. Ken is the building administrator, I think his title is actually a building administrator for the city of Ording, but he's essentially the flood guy for Ording. And when you think about it, Ording is right, the Puyallup River comes down, it's a steep grade river, and then it flattens out, and that's right where Ording is. So it's an area that has chronic flooding problems. So Ken is the guy that every year is out there sandbagging, or maybe not himself, but has major crews sandbagging the river. In 2006 and 2009, he was responsible for major evacuations of 20,000 people from the valley. So this has been a chronic problem going on, and following the restoration of these two projects that I just showed you, in 2014, last November, there was another big peak flow following the restoration of these projects. And the river didn't flood. It didn't jump the banks there. And so it's a great success story, not just that it didn't flood from that one storm, but the National Weather Service completely changed the flood standards of what a flood is on that stretch of the river. So we like to illustrate that this is a great example. If we put it in the right place, we can design it well. I think there's a lot of unknowns still looking forward. Is this still going to be a great success story in the future? We want to make sure we're designing these projects to do that. So I'll end there and take any questions, or we can move on to Guillaume's presentation.
I'm sorry, I'm a little slow with my questions. On the project underneath Ording, so there's also a lot of flooding below Ording and between before you get to the tide flats area.
Yeah.
Does any of the work in Ording help mitigate that, or is it just push the problem farther down the river?
Yeah, you know, that's it's a really tough question to answer, and it's changing really dramatically. Hopefully, maybe Eric will touch on this, because sediment is a huge issue in this river, right? So anything I say right now, it might change as that basin fills in, but it definitely alleviates flooding. We know that those projects alleviate flooding in Ording and upriver because it's helping the conveyance. I don't think there's any modeling or anything that would suggest it's exacerbating the problem lower down, but that first photo I illustrated really illustrates the problem. That river is so hemmed in through that valley there. Its development is so tight that there's no room for one more.
On the Skokomish River, we did much the same type of thing, and the sediment moved out. And so what it's doing is it's going out into the floodplain. One of the agricultural interests at the mouth of the Skokomish was worried that it would cause additional flooding or this type of thing. None of that is occurring. The material's moving out. It's actually creating habitat in the estuary, and the floods are being reduced.
Yeah, ideal scenario where we want the sediment going.